Deep in the mountains of southwest China, where the Jinsha River carves through ancient rock, stands a concrete giant that dwarfs most skyscrapers. At 289 meters tall, the Baihetan Dam looks like a curved wall of engineered defiance against nature itself.
The world's second largest hydroelectric power station after the Three Gorges Dam has begun operations.
While the world fixates on the Three Gorges Dam, this $31 billion mega project has quietly begun generating enough electricity to power entire nations. But there's also something unsettling about how fast it rose. Construction began in April 2017, and just 5.5 years later, it was fully operational.
The world's second largest dam has been completed, Baihetan Dam.
By comparison, the Three Gorges Dam took 14 years to reach the same milestone. So, how did China build something this complex in less than half the time? And what did they sacrifice to do it? The Baihetan Dam became fully operational in December 2022, yet most people have never even heard of it, which is extraordinary when you consider it's the world's second largest hydropower plant capable of producing 62 billion kilowatt hours annually. So to put that in perspective, that's enough clean energy to power the entire United Kingdom for nearly 2 months. But here's where it gets even more interesting. This represents a completely different approach to dam engineering. Unlike traditional gravity dams that rely on sheer mass to hold back water, Baihetan uses a double curvature arch design. Just picture a massive concrete bow stretched between canyon walls, using the rock formations themselves to distribute the enormous pressure of 20.6 billion cubic meters of water. At its base, the dam is 72 meters thick, tapering to just 13 meters at the crest. This engineering approach saved millions of tons of concrete and reduced construction time dramatically. However, the real breakthrough is in the turbines. Baihetan houses 16 Francis turbines, each capable of producing 1 gigawatt of power. These are among the largest hydro turbines ever built, each one weighing approximately 8,000 tons and standing 50 meters high. And the precision required to manufacture these giants is simply staggering. Each turbine has to be balanced to within millimeters to prevent catastrophic vibrations. But here's what they don't tell you about these turbines. These required entirely new technology from the ground up. Chinese engineers developed entirely new manufacturing processes just to handle the extreme forces involved. The runner blades alone weigh over 12 tons each and require breakthrough metallurgy to withstand tremendous water pressure and rotational speeds. The result? Turbines that achieve an efficiency rate exceeding 99%. Yet that level of precision raises a question that should concern everyone. What other technological advances are happening behind the scenes that we just don't know about? Here's what's truly unsettling about Baihetan's construction timeline. 5.5 years. That's how long it took China to build what many considered impossible. Most large dams take a decade or more to complete. The Three Gorges Dam took 14 years from start to full operation, but Baihetan was completed in less than half the time. The secret wasn't just throwing more workers at the problem. China deployed advanced construction equipment and developed innovative concrete technology specifically for this project. They used low-heat cement concrete, the first major application of this technology in hydropower construction, which reduces thermal cracking risks during massive concrete pours. However, here's where the story gets a little more complex. The logistics alone were mind-boggling. Limestone aggregate was sourced from quarries 50 kilometers away and transported up winding mountain roads to the construction site. Concrete had to be mixed to exact specifications and poured within precise time windows. A single mistake in timing could compromise the whole thing. Yet, this complex choreography proceeded without any major delays or setbacks. The dam's foundation sits on columnar jointed basalt, which required specialized engineering measures just to stabilize the rock mass. Engineers even deflected the dam axis by 5 degrees to improve geological conditions. They solved these problems in real time without missing a deadline. But here's what's really remarkable, and what reveals something about China's true capabilities. The speed suggests a level of preparation and technological readiness that had been developing for years before construction even began. This was the execution of a plan that had been perfected long before the world was even paying attention. But behind every mega project lies a human story, and Baihetan reveals something troubling about the price of progress. The dam's reservoir flooded an area roughly the size of Singapore, displacing an estimated 100,000 people from their ancestral homes. I mean, entire villages disappeared beneath the rising waters, along with archaeological sites that had existed for millennia. But here's what makes this particularly significant. The scale of these displacements receives almost no international attention. While Western media scrutinizes every aspect of infrastructure projects in democratic countries, China's massive relocations happen in relative silence. And the environmental impact extends far beyond the immediate area. The Jinsha River is part of the Yangtze River system, one of the world's most biodiverse waterways. The dam has fundamentally altered the river's flow patterns, creating barriers that prevent fish from reaching upstream spawning grounds. Species that evolved over millions of years now face obstacles they just can't overcome. However, the changes go deeper than just fish migration. Baihetan has transformed flowing river habitats into reservoir environments, conditions that are unfavorable for many native fish species. The change in water flow, temperature, and sediment transport has altered the entire ecosystem, with effects rippling hundreds of kilometers downstream. Local communities downstream have also reported changes in water quality and fishing yields. The dam's massive reservoir has likely created a new microclimate in the region, potentially affecting rainfall patterns and local agriculture. These are huge changes, and they're appearing to ripple outward, affecting ecosystems across a vast area. And yet, here's the paradox. The Chinese government argues these costs are justified by the dam's environmental benefits. Baihetan's clean energy production is expected to offset over 51 million tons of carbon dioxide annually, which is equivalent to removing approximately 11 million cars from the road. And in a world grappling with climate change, this represents a significant contribution to global environmental goals. But that raises an uncomfortable question. At what point does the environmental benefit justify the environmental cost? And who gets to make that calculation? Here's where Baihetan's true significance becomes clear. This goes far beyond electricity generation. It's about control. Baihetan's location on the Jinsha River places it at the heart of Asia's most critical water system. The Yangtze River Basin supports over 400 million people and generates roughly 40% of China's GDP. Control over this water source represents unprecedented power over the region's economic future. But the implications extend far beyond China's borders. The Yangtze River system connects to waterways that flow all through Southeast Asia, affecting countries like Vietnam and Cambodia. China's ability to control water flow through dams like Baihetan gives it significant leverage in regional politics. But here's what's really concerning. India has expressed particular alarm about China's dam building program. As China constructs more dams on rivers that flow into South Asia, questions arise about water security and regional stability. Baihetan represents just one piece of a larger strategy that could reshape the balance of power across Asia. But there's something else that should grab your attention too. Every major component of Baihetan was designed and manufactured domestically. 8 turbines by Dongfeng Electric and 8 by Harbin Electric. This represents a dramatic shift from earlier projects that relied heavily on foreign expertise and equipment. China just doesn't need outside assistance to build mega projects of unprecedented scale. That technological independence has profound implications for global competition and security. The construction of Baihetan required innovations that simply pushed the boundaries of engineering science. The dam's low-heat cement concrete was developed specifically to reduce heat generation during curing, preventing the thermal cracking that's plagued other large dams. This represents a breakthrough in material science that's now being studied for application in other major projects. But here's where it gets really interesting. The turbine design incorporates advanced computational fluid dynamics that optimize water flow through the generators. These calculations required sophisticated computer modeling that just would have been impossible a decade ago. The result is turbines that operate at efficiency levels previously thought impossible. However, perhaps most impressive is the dam's monitoring system. Embedded safety monitoring instruments were installed during concrete pouring to continuously measure stress, temperature, and movement. This data feeds into systems that can predict potential problems before they become critical. The dam essentially monitors its own health in real time. Yet, here's what's truly remarkable about the construction process. Engineers created detailed virtual replicas of the dam before breaking ground, allowing them to identify and solve problems in the digital realm. This approach eliminated costly delays and redesigns that typically plague large construction projects. But this also raises a critical question. If China can build virtual replicas of massive infrastructure projects and solve problems before they even occur, what other capabilities are they developing that we don't know about? Baihetan's success has implications that extend far beyond hydroelectric power. The construction techniques developed for this project are already being applied to other infrastructure projects across China. The rapid construction methods could revolutionize how the world builds large-scale infrastructure. But here's what's really significant. The turbine technology has potential applications in other renewable energy sectors. The precision manufacturing processes developed for Baihetan's generators are being studied for adaptation to wind turbines and other clean energy equipment. This technological spillover effect multiplies the project's impact on China's industrial capabilities. However, international engineering firms are studying Baihetan's construction methods, trying to understand how China achieves such rapid completion times. Some techniques are already being incorporated into projects in other countries, spreading Chinese engineering influence globally. Yet, the project has also accelerated China's development of construction automation. Many processes that required human workers at previous dam sites were automated at Baihetan, improving both speed and safety. These automated systems are now being deployed on construction sites worldwide. But here's the bigger picture. China's developing capabilities that could be applied to any large-scale construction project anywhere in the world. Baihetan represents more than just another dam. It's proof of concept for a new era of mega-scale engineering. The project demonstrates that massive infrastructure can be built faster and more efficiently than previously thought possible. This capability has profound implications for addressing global challenges like climate change and urbanization. But here's what really should get your attention. China's announced plans for even more ambitious projects, including dams that would dwarf Baihetan in size and complexity. The lessons learned from this project are being applied to proposed structures that would reshape entire river systems. However, questions remain about the sustainability of this approach. Can the rapid construction methods used at Baihetan be applied safely to even larger projects? The long-term performance of the dam will provide crucial data for future projects. Yet, the international community watches these developments with a mixture of admiration and concern. China's demonstrated ability to build massive infrastructure quickly gives it significant advantages in global competition, but also raises questions about environmental and social costs. The completion of Baihetan Dam marks a turning point in global infrastructure development. China's demonstrated that mega projects can be completed in timeframes that seemed impossible just a few years ago. This capability reshapes what's possible in addressing global challenges. Climate change requires massive infrastructure investments in renewable energy. Baihetan shows that such projects can potentially be built quickly enough to make a meaningful difference in global carbon emissions. The dam's clean energy production, equivalent to removing millions of cars from the road, demonstrates the potential impact of rapid infrastructure development. But the project also highlights a growing technological gap between China and other nations. The engineering capabilities demonstrated at Baihetan represent years of focused investment in education, research, and industrial development. Other countries may struggle to match this level of technical achievement. However, here's the geopolitical reality. China's ability to build massive infrastructure projects quickly gives it considerable soft power in international relations. Countries seeking rapid development may increasingly turn to Chinese expertise and financing. Yet, as we look toward the future, Baihetan Dam stands as both an achievement and a warning. It shows what's possible when a nation commits fully to mega-scale engineering, but also raises questions about the cost and consequences of such rapid development. The world's second-largest hydropower plant operates quietly in the mountains of southwest China, generating clean energy and demonstrating capabilities that few thought possible. Whether this represents the future of global infrastructure development or a cautionary tale about the pace of change remains to be seen. But here's what's certain. The age of mega-scale engineering has arrived, and China has shown the world what's possible when ambition meets capability. The question now isn't whether other nations can keep pace with this new reality. The question is whether they can afford not to.